Okay, good morning all. So, so yesterday we saw how to sort of run C# code, and so by now I believe you have made those settings so that you can run using the run button in the UI and also in the terminal. All right. So now let's look at some concepts in some basic introduction to C# programming. So you all know the basic primitive data types in C, right? So what are those? Yeah. Can you name some? Int, float, double, char. Okay, right. And can you tell me what is the size of each of these data types in bytes? You know what is a byte? So what is a byte? Yeah, 8 bits, right? Yeah. So int size is, or char size is what in terms of bytes? So the more number of bytes you have, the more the greater the range of variable, the range of numbers that you can store, right? So char size is 1 byte. So number of bytes. Yeah. So char is 1 byte. So 1 byte means 8 bits. 8 bits means what is the range of how many different values you can store using 8 bits? Suppose if you have only 1 bit, how many values you can store? You have space for 1 bit. How many values you can store in that space? How many different values you can store? Zero or 1. So 2 values. If you have 2 bits, how many different values you can store? Yeah? 4. Right? First bit can be 0 or 1 and second bit can be 0 or 1. So first bit has 2 possibilities, second bit has 2 possibilities. If you have 3 bits, how many different values you can store? 2 power 3. So 2 into 2 into 2, right? So if you have k bits, how many different values you can store? 2 power k, right? So each position has 2 possibilities. So when you have k positions, you have 2 into 2 into 2 and so on, k times. So 2 power k different possibilities, right? So 1 byte means how many bits? 8 bits. So 8 bits means how many different values you can store? 2 power 8. 2 power 8 is? Yeah? 256. So 256 different values you can store, right? So if you remember something called ASCII table, you know of ASCII table? So what is ASCII table? Yeah? Yeah, every character is assigned a number. Okay? Now, most of the characters, at least say in English, and the digits and the symbols and the punctuation marks, all this, maximum they are 128. If you include some more special characters, like some European languages, they write English but with some accents, with some marks, punctuation marks on top or at the bottom, something like that. So if you include those characters also, you will have maximum 256. So you can represent all these characters using 8 bits or 1 byte, right? So this is ASCII table. You all know. Right now, ASCII basically means 128 characters. So actually 7 bits are sufficient to represent all the regularly used characters. But if you want to incorporate some more, like I said, European language characters, you can extend ASCII. So that is called extended ASCII. So that will use 8 bits. So you can represent 256 characters. But all the regular characters that we use, they fit in 128 characters. Okay? So the number goes from 0 to 127. Why? Not from 1 to 128, but 0 to 127. Why? If you have 1 bit, what is the maximum number that you can represent? One. If you have 2 bits, what is the maximum number that you can represent? See, if you have 1 bit, it can be either 0 or 1. If you have 2 bits, it can be 0 0 or 0 1 or 1 0 or 1 1, right? Similarly, if you have 3 bits, it can be 0 0 0 0 0 1 0 1 0 0 1 1, and again 1 0 0 1 0 1 1 1 0 1 1 1. So the maximum number that you can represent in any bit representation with k values or k spaces is all ones, right? So here, when you translate these to decimal values, this will be 0, this will be 1, this will be 2, this will be 3, okay? And here the decimal values are, this will be 0, this will be 1, this will be 2, this will be 3, 4, 5, 6, 7. How are we converting them to decimals? Yeah, you take any binary representation, let's say this one. To convert it to decimal, you see, these are in decimal system, what do we call? This is units place, this is tens place, this is hundreds place. Okay, that is because in decimal system the base is 10. All right, in binary system the base is 2. That's why it is called binary system. Okay, in hexadecimal the base is the name itself tells you what? Hexadecimal. Yeah, 16. In octal system the base is 8, right? So if your base is n, your digits go from 0 to n minus 1, right? That's why in decimal system the digits go from 0 to 9. In binary system the digits go from 0 to 1. In hexadecimal the digits will go from 0 to 15. In octal the digits will go from 0 to 7. Okay? So depending on the base, each place will be equivalent to the power of that base. In decimal system, this is, why do we call this is units place, this is tens place, this is hundreds place? Because units place means this is 10 power 0, tens place means this is 10 power 1, hundreds place means 10 square, and thousands place means 10 cube, and so on. So it is a power of 10. if it is in decimal system. If it is in binary system, this will be units place, twos place, fours place, eighths place, and so on. Okay, so all you need to do is take the corresponding digit in that place and multiply it with the place value and add all the products. Okay, so suppose this is in decimal system. If you multiply it with the place value and add all of them, you will again get the same number that is unique only to decimal system. Okay, like 1 into 10 power 0 plus 0 into 10 power 1 plus 1 into 10 square. Okay, so what will that be? 1 into 10 power 0 is 1 plus 0 into 10 power 1 is 0 plus 1 into 10 square is 100. So you will again get 101. Okay, but suppose it is in binary system. Okay, you see any number, just when the number is written to you, you don't know the numerical system in which it is written. By default we take it to be decimal, but technically one has to specify it is in decimal, or one has to specify it is in binary, or one has to specify it is in octal. One has to specify the numeric system. Only then you will know that number's actual value. Otherwise it is just a sequence of some digits. Okay, by default we take it to be in decimal, but technically one has to specify that it is in decimal. Alright, so if it is in if I had written that it was in decimal, then this 101 sequence value is the number 101. Okay, but suppose if I write it as being in base 2, then 101 sequence value is what is the equivalent decimal number? How do you get the equivalent decimal number? Same method, whatever I said. So 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 square. So what is it? 1 plus 0 plus 4, that is 5. So this is in decimal. So 101 is not 101. 101 is some sequence of digits. Its equivalent numerical value or decimal value is 5. So 101 value is 5. Okay, but in decimal 101 sequence value is 101. Okay, so that is the difference. So what is the largest number that you can represent using 3 bits? 111, right? So all you need to do is consider the place values of these bits and add them all. So it is like 2 square plus 2 power 1 plus 2 power 0, that is 4 plus 2 plus 1, that is 7, right? So do you see a pattern? When you have, so when you have 1 bit, the maximum value is 1 that you can represent. When you have 2 bits, the maximum value that you can represent is 3. When you have 3 bits, the maximum value that you can represent is 7. When you have 4 bits, the maximum value that you can represent will be 15, exactly. How are you getting that? Exactly. So when you have k bits, the maximum value that you can represent is 2 power k minus 1. And the minimum value that you can represent in all these cases is, no matter how many bits you have, the minimum value will be 0. So your range is 0 to 2 power k minus 1. But the total number of values will be 2 power k. Okay, so that is the difference. So when you have k bits, the range is 0 to 2 power k minus 1, but the total number of values will be 2 power k. Okay, similarly, So sorry, so that is why in this ASCII table you are using 7 bits. 7 bits means 2 power 7 total number of different values that you can store. 2 power 7 means 128. So total number of different values are 128, but the range is 0 to 127. Okay, so every character that you already know, that character has a number here, right? So here these are all non-printable characters. That is why this is sort of not shown. Okay, these are printable characters like space, exclamation mark, double quotation, hash, and all those things. And then the digits 0, 1, 2, 3, 4. These are also characters when you print them. Okay, so if you have to print 0, it will find its ASCII value and store this character 0 as number 48. Because finally everything should be converted to numbers. Everything should be converted to zeros and ones in the computer, right? So 0 is not stored as 0 in the computer. The character 0 is first converted to 48. 48 is converted to binary, and the binary form of 48 is stored in the computer. Okay, so each character is like that, small a or capital A. Capital A is 65. So if I have to store capital A, it will convert it to 65 and store it. Okay, so that is the thing. So that is ASCII values. So char in C takes only 1 byte, that is 8 bits. So using 8 bits, you can represent all English characters and all punctuation symbols, all digits and all those things you can represent. Okay, so 1 byte is sufficient to handle characters. And int, how many bytes? Do you remember? Okay, int takes 4 bytes. So the range of numbers that you can represent. Now 4 bytes means how many bits? 4 bytes means how many bits? 32. So 32 means total how many different values you can represent? 2 power 32. Yeah, and the range will be 0 to 2 power 32 minus 1, right? But suppose if I want to represent negative numbers, sorry? Not into 2. Given the same space, you have to accommodate negative numbers as well. So a simple thing is you divide them into half, and I mean brute way of saying it is you reserve 1 bit as a sign bit. So if the first bit is 0, you consider that to be positive. If the first bit is 1, you consider the remaining number to be negative. So first bit does not add to the magnitude of the number, it is only a sign. So only 31 bits are reserved for the magnitude, 1 bit is for the sign. So now your magnitude is reduced to 31 bits. So 2 power 31 values you can represent. Okay, so if it is 0, you can represent 2 power 31 positive values. If it is 1, you can represent 2 power 31 negative values. Okay, but technically that is not exactly how it is done. We use 2's complement, signed magnitude. These are different things. This is just a what do we say, simple way of understanding, but it is done slightly differently. But simple thing is you have 32 bits. In that case, your range is normally from 0 to 2 power 32 minus 1. But if I reserve one of these bits as sign bit and I have remaining 31 bits, right? So in that case, these bits range is 0 to 2 power 31 minus 1. Okay, and this will be plus or minus. All right, so one way of understanding is this will be minus 2 power 31 minus 1 to plus 2 power 31 minus 1, right? But in this case you will have 0 two times, minus 0 and plus 0, but both are same. So instead of wasting a space for 0, one of these zeros, whatever is the binary representation, that is used to represent one more negative number. So it will be minus 2 power 31 to plus 2 power 31 minus 1. So that is what happens if you use 2's complement. Okay, so we will not get into that, but the point is the range of numbers that an integer data type can store is much larger. A char type can store only 0 to 255. Okay, int can store minus 2 power 31 to plus 2 power 31 minus 1. All right, and float is again 4 bytes. Double is 8 bytes. Float and double, again the difference is the range and also the precision. The decimal value, suppose in float you can store only up to a precision of 6 decimal values. If you try to store more decimal values, it will round them up to 6 decimal values. Okay, but in double you can store maybe up to 12 decimal values or 10 decimal values. I don't know the exact number, but something like that. Okay, so this is in C. Now again in C there are there is one more, there are two more types: short int, that is 2 bytes, and long int. So for short and long you need not write int every time, you can just write short or long, that is also enough. Long int is 8 bytes. Okay, so their range is again according to the number of bytes. 2 bytes means 16 bits. So short int range will be minus 2 power 15 to plus 2 power 15 minus 1. Similarly, long int range will be 8 bits means 8 bytes means 64 bits. So minus 2 power 63 to plus 2 power 63 minus 1. Okay, so that is the range. Now almost all these types carry forward to C# as they are, with some minor differences. In C#, you have something called byte. So this byte is, you see, in C, char is technically not a different data type. Char is fundamentally an integer data type only. It is like 1 byte integer. We just call it char, but it is integer. That is why you can add characters, you can subtract them, you can compare two characters. Is A less than D, A in single quotes, D in single quotes. That will also evaluate, right? Because it is actually converting them to decimal. What is the ASCII value of A? What is the ASCII value of D? So is this ASCII value less than this ASCII value? Or I can also do A plus 3. It will give me D. Because A's ASCII value is added to 3 and you will get the ASCII value of D and you can print D. Okay, so you can treat characters as numbers in C. Okay, because char is fundamentally an integer data type. So if you want to use very small integers, say if you know the range of your integer values is very small, then rather than allocating 4 bytes, you can just use char. Suppose if I want to store the ages of different people, I know it can't be more than 255, definitely. So instead of saying int age, it will unnecessarily use 4 bytes for age. 4 bytes means 2 power 32, 2 power 31, all those things. Why so much space being wasted? It will be hardly 100, max 110, 120, something like that. So 1 byte is more than enough. So I will use char. So I will say char age equal to whatever, 30, 50, 22, whatever that is. Okay. So when you know your number range is very small, use char. Don't need to use int every time. Okay. But in C#, the equivalent one is byte. not char, it is byte. So byte is 1 byte integer, okay, and remaining are same. Short is short int, that takes 2 bytes, and int takes 4 bytes, and long int or long takes 8 bytes, okay. And in real numbers we have float that takes 4 bytes, and double that takes 8 bytes. We have one additional real number data type in C#, that is called decimal, that takes 16 bytes. So one is decimal's range is much larger, and decimal's precision is much larger. Like, for many scientific applications we require a very large decimal precision. In those cases it is better to use decimal data type, okay. And then here we have a char data type, okay. This is a different data type than integer. This can store only characters, okay, and its size is 2 bytes, that is 16 bits. Now why do we need 2 bytes or 16 bits to store characters? Only characters, not even numbers. Anyone? Special characters means like ASCII is anyway 8 bits are sufficient for ASCII. Asterisk. No, those are all keyboard characters. You will get them in ASCII. Punctuation marks, all keyboard symbols you will get in ASCII. What are the kind of special characters that are not covered in ASCII? Have you heard of Unicode? No. Have you ever wondered how emojis are stored? Emojis are also special characters. And forget emojis, how you are able to type in Hindi, Telugu, local languages. What about those characters? Right? Those characters do not fit in 8 bits. You need more numbers, right? Because 255 numbers, they are all reserved for known characters, some English characters and some other characters. But what about Telugu characters, Hindi, Tamil, Chinese, all these different languages in the world? What about those characters? Right? So to accommodate those characters, we need to increase the range of our numbers, right? So beyond 255, now I can map 256 to maybe start 256 to characters in Hindi, whatever they are. So 256 is 257 is or something like that. So I need more range of numbers so that I can assign more numbers to more characters. For me to store these more numbers, I need more bits. So I increase my encoding system size to 2 bytes. So now since it is 2 bytes, it is 16 bits. So now my range is, I can store 2 power 16 different values. So my range is 0 to 2 power 15 minus 1. In char there is no need of negative numbers. So it is just 2 power 0 to 2 power 15 minus 1. Sorry, 0 to 2 power 16 minus 1. Right? Yeah. So many different numbers I can store. Alright. And much more. Unicode, there is 16-bit encoding and there is also 32-bit encoding. Using 32-bit encoding, much more you can store. Okay. So right now this uses in C# char uses 16-bit encoding. It is Unicode encoding. So basically to store non-English characters, like to store different language characters and to store emojis and those kinds of things. Okay, so char here takes 2 bytes, whereas in C char takes only 1 byte. Alright, and we also have another data type, that is bool. So what is bool? Boolean. Yeah, that's all. So Boolean takes only 2 values, true or false. Okay, in C we don't have bool by default. If we want to use that, we need to include a particular library called ctype.h. But by default we just use 1 and 0 for true and false in C. But in C# and many other languages we have bool as a separate data type. Okay, so here also we have that. Fine. So these are there are other data types also, but these are the most regularly used data types in C#. Even among them, int is mostly used, short and long. Long is used sometimes, but short is rarely used. Okay, byte is also rarely used. So anyway, these are some regularly used data types, and each of these data types finally they are mapped to .NET data types, because .NET, like I said, is a framework which can be used by more than one language. So C#, Visual Basic .NET, so or F#. So there are different languages which can use .NET framework, and finally everything is converted to .NET syntax and compiled. Okay, so this is the ASCII table, and this is the equivalent, or so each of these data types are finally converted to .NET data type by the compiler. So the compiler actually understands this before translating them to machine language. It first converts them to .NET type and then converts these .NET types to machine language. Okay, so that is what happens. So we just saw all this. So on the leftmost here you see basically 4 categories: integral numbers or different types of integers, then real numbers and character and boolean. Okay, and so integral numbers you have byte, short, int and long. Byte takes 1 byte, short takes 2 bytes, int 4 bytes, long 8 bytes. Okay, and the real numbers, float, double, decimal. Float is 4 bytes, double is 8 bytes, decimal is 16 bytes. Character, char takes 2 bytes, and boolean, bool takes 1 byte. Okay, and for each of them you see the equivalent .NET type. Okay, all the data types in C# they are all of smaller case, lower case, whereas in .NET type all begin with an uppercase. You need not really worry about these .NET types because you will be using only the C# types. The compiler will take care of converting these to .NET types. But we will see it is better to understand that what are the corresponding .NET types, because say when we are analyzing a code, it will show .NET types instead of C# types. So you will understand, okay, this type corresponds to this type in C#. Alright, so byte in C# with small b is converted to byte with capital B in .NET type, and so on. Each one you can see. And the range you can see, that is because of the number of bytes and number of bits, and that is in terms of powers of 2. Okay, so you can see that. All right, yeah, so now let's do some basic coding. All right, so anyway, so let me close this. So let's open command palette, new project, console app, and let me name it, say, variables, or let me name it data types. Okay, now one more thing in variables, one is variables. Another is constants, right? You would have heard of constants. So you can declare something as a const variable. I mean, const is not really a variable, it's a const data type. So before a data type, if you put a const keyword, it means you cannot change that value of that name of that variable even by mistake. Like for instance, we use constants like pi, right, or e. Sometimes we use those constants. We store them in some variable name and we want to use them. But suppose accidentally they are changed, then our program is disturbed. So to avoid that, we put a const keyword before them so that they are not changed later. Okay. So anyway, we will see that. So let me type using system and then namespace. So let's say namespace data types and class just a program, and then static void main string args. You see, like if you remember yesterday, what did I say? The basic building blocks of a C# program are classes, and you can group related classes into a namespace, and you can group related namespaces into an assembly, and one or more assemblies make up an application, right? So in this case, system is a namespace within which you have already existing classes like console, and console has a method like writeLine, like this is what we saw in the last class, right? So this console is predefined. This console is a class that is predefined in the namespace called system. That is why we had to include system namespace to be able to use this console class. And what is a class? What does a class have? What does a class consist of? Sorry? References. Not references. Class consists of, what is the what constitute a class, like what kind of things you have in a class? Methods and data. Yeah. So this writeLine is a method inside the console class. Okay. Method means function. So function inside a class is called a method. Alright. So inside console there are many methods, out of which writeLine is one method that is like printf, and then to read, that is like scanf. So we have different methods, and you can see the suggestions of IntelliSense, like as you start typing, you see the suggestions here, right? writeLine is being suggested, right? So you press tab, that will be autofilled. Okay, so all the methods inside that class will be visible as you start typing, and you can select one of them. All right. Okay, and now what we are doing, we are creating a new namespace, and we have defined a new class in which we have written a main function in which we will write whatever we want. Okay, this can be a class which can be used either by our own program or by some other programs. So we can define our own namespaces, our own classes, our own functions. All right. So right now, let's basically, what do we say? Initialize some variables. So let's say byte, number. Now I can choose to give a value right there, or I can choose to give a value later. Okay. But until you give a value to a variable, you cannot use it in any other expression. You cannot use it in any command, in any function. Like suppose right now I'll give a value. Okay. And let's say I want to print it. Console dot writeLine number. Okay. I just want to print it. So let's print, let's run this. Okay, I am in the wrong folder. I need to move to this folder in the terminal. So I need to / datatypes. Okay, now let me run this. You see it printed 1. All right. Now suppose I don't give this 1. I just declare the variable. I don't give a value to it. And if I try to print it, let's see what will happen. It's not printing. Because unless you initialize a variable, you cannot use it anywhere, even in a print statement. Because what will it print? It doesn't have a value yet. So you can't print it, you can't use it in an arithmetic expression or any expression, you can't add it to some other variable, you can't do any of these things. Okay? Whereas in C you can do that. It will print some random value. It may initialize it to 0 by default, then it will print 0. Or if it initializes it to some random value, it will print that value, right? But C# is more strict, right? So it will force you to do proper coding, okay? But C, etc., they allow you to get away with improper coding. All right, so this is one thing. So let us give it value, let's say 20 right now. And another thing, all the names, all the variables, all the names are case sensitive. So suppose if I try to declare this again, it will give an error, right? Because it is already declared, right? So let's try to run it. It gave an error because number is already declared. But suppose if I change its first letter, case, okay, now it should not give an error because they are of different cases. First variable is different, second variable is different, because even if one letter case changes, it is a different variable, it's a different word altogether. Okay, so they are case sensitive. So don't even by mistake use a different case thinking that it will work. It won't work. You should remember the case. Which case did you use? If you used all small letters, or the first word is a capital letter, and all those things. So for that, it is better to follow a particular what do we say? A particular method, like a particular naming convention. So if you have multiple words in your variable name, suppose my variable name is say first name, then there are multiple ways of writing it. I can say first name, that is I capitalize the first letter of each word in the multi-word variable name, or I capitalize only the, I keep only the first letter small and all the remaining words letters capital. First name of my friend. There are many words, except the first letter, all the remaining words are capitalized, first letter. First words, first letter is small. Okay, so this is a better method to follow, because mostly C# developers follow this method. First words, first letter is small, all the remaining words, first letter is capital. Okay, this is for variables. When you are using a constant like pi or any other constant, in that case you capitalize all the letters including the first words, first letter. That's the only difference. Okay, in variables case, capitalize all the letters of all words except the first word. In the constants case, capitalize all words, first letter. That's the only difference. Okay, so just follow this routine so that it is easy. You don't get confused, okay, which, or if it is too confusing, just follow only one method for variables, for constants, everything. Capitalize all the words first letter, or capitalize all the words first letter except the first words first letter. Just follow one method so that you will always remember, okay, this, I need not get confused which words are, which letters are capital, which letters are small. You need not worry about that. Okay, so that is one thing. So byte we saw, and say char ch equal to, let's say, a, and character you always put in single quotes. Okay, if you don't put single quotes, what will happen? what will happen? Will it give an error? What will it do? See, if you don't put single quotes, it will assume there is a variable with that name and it looks for that variable. So it is like, suppose I say byte a equal to 15. Now a is a variable. So here it is trying to look for the variable name a and try to map its value to ch. But you don't want to map the variable's value, you want to map the letter a. So you have to put it in single quotes. Okay. So that is scat and int whatever, say int age equal to 30 and what else, short, you can't use the same variable name, you can say short count equal to 5, long distance equal to some very large number, and float, rather than giving xyz kind of arbitrary names, better to give meaningful names. All right, float height equal to 2.3, double weight equal to 54.6 whatever, and decimal whatever, radius equal to 8 point some large decimal value. Okay, you see parallelly while you are typing itself, here you are seeing some number 9, okay, and here you are seeing problems 11. So it is actually sort of telling you either warnings or errors. Okay, so it is better to rectify your program before you compile. All right, now all these are there. So right now let me comment these two. All right, and let me copy this line. So I'll just print all this. So you see each problem is getting deleted because it is basically expecting us to use these variables. It's a warning, it's not a problem per se. Some are really problems, you have to rectify them. So I print ch, age, count, just 2 minutes, distance, weight. Okay, yeah, so this is of a different code, so you need not worry about that. So that code I am not working on right now. So in this code all the problems are resolved. You see in this code there is no more number beside this, all the problems are resolved. So I can happily compile it. Okay, run it. Yeah, it printed all the values. Fine. Now why did I comment these two? Let me uncomment one of these. So let me uncomment float line, and it is saying some problems. You see, literal of type double cannot be implicitly converted to type float. Use an f suffix to create a literal of this type. So what it means is, you see, C#, when you give a real number like this in the RHS, by default it takes it to be of type double. Okay, but if you want to store it as type float or type decimal, you have to explicitly convert it or explicitly mention that. Okay, how do you do that? Just by putting a letter called f, so that now 2.3 will not be taken as double, 2.3 will be taken as float. Okay, if you want to use it as double, then you need not give anything, but if you want to use it as float, you should give f, and if you want to use it as decimal, then you should say m. Okay, now you will not get any errors. You see, I didn't print them, so let me print them. height, radius. Okay. Yeah, it printed all those. Okay. So this is one thing which you need to remember when you are using decimal real numbers. If you are using float, always ensure that you put an F at the end. Small f or capital F, it doesn't matter. Similarly, if you are using decimal, you should put an M at the end. If you are using double, you need not put any suffix. Okay, so this is one thing. Yeah, so these are basic data types and their sizes and other things. We will discuss more things in the future lectures. So let's stop here.